This is the test 5.1 review for academic math, transformations, and scatter plots. So we're going to start right off with scatter plots. A carpenter recorded the amount of money he earned from different jobs and the amount of time he spent on each job. The data are shown in the scatter plot below. So number one, based on the data, how much money would the carpenter earn for 5 hours of work, and what about 9 hours of work? So we're making a prediction on a scatter plot. So the first thing we need to do is draw a trend line that represents our data. Okay. So for 5 hours, we're going to go over to 5 on the x-axis, and we go up until we meet our trend line. So for 5 hours, that's about $1,250. And then it asks us about 9 hours, so same thing, go over to 9, up to your trend line. That's about $2,250. Number 2, according to the graph, the relationship between the carpenter's earnings and the amount of time he spent on the job is, that is a positive correlation. As one variable goes up, so does the other. Number 3. Create a scatter plot from the data in the table. Hours is our x, weight loss is the y. So we're going to put our hours along our x-axis. So our first point is 1.5 and 0.5. So 1.5 and 0.5. We're going to put a dot right there. 3 and 3. 5 and 3.5. 2 and 2.5. And then 4 and 4. So there's our scatter plot. We're going to draw a trend line. Remember, make your trend lines as straight as possible. Number 4 asks us about what type of correlation. This is positive, just like with the carpenter. How much weight do you think he would lose if he exercised for 7 hours a week? So we're going to go over to 7, up to our trend line. About 6 pounds. Number 6. If Carson continues to travel at the same rate as shown in the trend line, how many miles will Carson travel after 9 hours? Round to the nearest whole number. So 9 isn't anywhere on our x-axis. Our x-axis goes up to 4.5. But I know that 4.5 goes into 9 twice. If I take 4.5 and I multiply by 2, I get 9. So if I know how many miles they go in 4.5 hours, I can estimate how many miles they would go in 10. So 4.5 times 2 is 9. So if they go 10 miles in that time, multiply that by 2, that would be about 20 miles. Number 7. The graph shows the cost of making a bicycle for different numbers of miles. If Natalia rides a bicycle for 15 miles, what is the cost in dollars? So this problem is exactly like the one before. We're going to draw our trend line. Okay. Find a point on your line so that you can set up a proportion. So at 5 hours, we know it costs $6. Or sorry, 5 miles. So 5 into 15, well, that goes in 3 times. So for 15 miles, we would do 6 times 3, and we get $18. Number 8, if you were to draw a trend line in this graph, name 2 points. All you need to do is list 2 points on your graph. I've got 5, 6 on my trend line, and then 3 and 5.5. Classify each scatter plot as linear or nonlinear. So linear means it can make a straight line. So here for this first one, I can draw a straight trend line, so that's linear. Here, that's a bit of a circle. So that would be nonlinear, it curves. Linear, Okay, down here, we see there's a bit of a pattern, but that's a curved line, so that's non-linear. Non-linear. And for this last one, we really don't have any correlation, so no correlation is the same as non-linear. Non-linear. Okay. Which set of transformations produce a figure that is congruent to the original figure? So now we're looking at our transformations and which ones are congruent. So if I rotate an image, that does not change the size, so rotations are congruent. If I dilate an image by a scale factor of 0.5, I know that my image is going to become half of its original size. Well, if one image is half of the other, that is not congruent. A translation, that's a slide, that's going to be congruent. Because one of these is not congruent, letter A is not one of your answers. A reflection, that's a flip, that's congruent. Oh, we have a dilation again, so can't be letter B. Translation, rotation, and a reflection. All three of those transformations produce figures that are congruent, so it's letter C. Number 11, define the different types. So a reflection, that's a flip. A rotation, you're taking the image and you're going to turn. A translation is a slide. So we're taking that image and we're just moving it up, down, left, or right. Dilation, that's either an enlargement or a reduction. So this is the only one that is not congruent. Okay? Dilations are not congruent. Number 12. Find the coordinates of a triangle with vertices at A is at -1, -5. B is at -7, 0. And C is at -3, 4. So there's our triangle. After a rotation of 180 degrees clockwise. So if I rotate something 180 degrees, I know that I just need to change the signs on my x and my y's. So for A, it's at -1, -5. A prime is at 1, +5. That's A prime. B prime is at +7, 0. And C prime is at 3 and then -4. So all we're doing is flipping the signs from positives to negatives or negatives to positives. And there would be your new triangle. Number 13. Quadrilateral ABCD has coordinates at -2, 4, B is at 4, 6, C is at 7, -2, and D is at -3, 1. What are the coordinates of A prime if the original quadrilateral is translated 6 units to the right? So if I'm going to the right, that's a change in my x. So we're only looking for A prime. So we're going to start with A. To the right is x, and because it's positive, we're going to do x + 6. So for A prime, I'm going to take my x value, which is -2, and add 6 to it. And then my y is going to stay the same. So A prime, -2 + 6 is 4, and 4. The algebraic rule, because that's the second part of the question, is just what you did in that translation. I added 6 to my x's, and my y stayed the same. 14. Find the coordinates of the vertices of the image of J, 0, 6, K, -4, -7, and L, -5, 1, reflected across the x-axis. So reflection across the x means we're going to change the y to a negative. So if I've moved something across the x-axis, it's going up or down. So to find the coordinates for j prime, x stays the same, my 6 becomes negative. K prime, negative 4 stays the same, my 7 becomes positive. L prime, negative 5 stays the same, my 1 becomes negative. 15. What are the coordinates of point P after it's reflected over the y-axis? So same idea as the last question, except now that we're flipping it over the y, my x becomes negative. So then P prime, my negative 8 becomes a positive 8, and my 11 stays negative. 16. Translated 13 units to the right, so that's going to be x plus 13, and 12 units down, that's going to be y minus 12. So my algebraic rule turns into x plus 13 and y minus 12. What are the coordinates of the new point? So all we're going to do is take negative 5 plus 13 and 0 minus 12. And then just simplify. Negative 5 plus 13 is 8, and 0 minus 12 is negative 12. Number 17. If point A at negative 3, 2 is translated under this rule, x minus 5, y plus 1, what are the new coordinates? So A prime, we're going to take negative 3 and minus 5, and then 2 plus 1, and then simplify. So A prime is at negative 8 and 3. Which representation below does not preserve congruence? So, does not preserve congruence means we're looking for a dilation. So, first, get rid of all of the rules that aren't a dilation. A here, that's a translation, plus or minus. So it's not A. Letter D, this rule is written backwards. So remember, all of your rules have to have the x, y first and then the arrow. So it's not letter D. Letter C, negative x, negative y, that's a rotation. Because there's no scale factor here. Letter B is the dilation. Our scale factor is 2, which means the image is going to get double the size. Number 19. Write an algebraic rule that represents the information shown below. So this is a dilation. So we need to find a scale factor first. So to find the scale factor, you divide one of the new sides by the old sides. So here, this is my new image. I know that side is 4. The corresponding side on the original image is 8. So new over old, 4 over 8, 1 half. That's my scale factor. So now when I write my rule, I just put my scale factor in front of the x and the y. That means I'm making my image half the size that it started at. Number 20. Label the quadrants of the coordinate plane. So 1, 2, 3, 4. Plot your points. So A is right there. B is at negative 6, negative 3. C is at negative 4, negative 8. And D is at negative 2, negative 3. And that's D. There we go. Translate the image 9 units to the right and 10 units up. So all we're going to do is take each of our points and we're going to count 9 units right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. and 10 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's D prime. D prime. 1, 2, 4. One more. A prime. And C prime. So there's your new image. What are the new coordinates? So you're just going to go through and list each of the coordinates. So A prime is at 1, 2. B prime is at 1, 2, 3, 7. C prime is at 5, 2. And D prime is at 7, 7. What quadrant is A prime, B prime, C prime located in? Well, it's in quadrant 1 because we labeled that. Reflect the parallelogram over the y-axis. So we're going to take our parallelogram and flip it over the y-axis. Label that double prime. And there's your new image. Okay, number 24. Translate triangle ABC 3 units to the left and 2 units up. So 1, 2, 3, up 2. A prime, B prime. So again, you're just counting, and then list the new units. So -1, 5. B is at 2, 8. And C is at 5, 6. Rotate the triangle 90 degrees. The algebraic rule for that is y negative x. So all we're going to do is flip So we're taking our original triangle ABC, and we're going to turn it 90 degrees to the right. And to find our new points, all we're going to do is take our original coordinates and flip them, and then make your x negative. So A is at 2, 3. That turns into 3, negative 2. B is at 5, 8. So that turns into 8, negative 5. And C is at 8, 4. And that turns into 4, negative 8. So those would be the coordinates right here of your rotated figure. Number 25. If trapezoid JKLM was rotated 180 degrees clockwise, determine which rotation would represent the new coordinates. So if we're going to rotate it 180 degrees clockwise, and guys, this is just one of those rules that you have to remember. If we're going to rotate it, all of your coordinates just become the opposite of what they are. Okay, so nothing flips, nothing changes. All that's going to change are the signs. So for example, J is at -3, -3. So the rotation would then be at +3, +3. So J prime would be over here. And then if you do that for each one, you would see that the rule is -x, -y. So go ahead and finish finding each of your new points and rotating the trapezoid. And number 26, the manager of a restaurant recorded how many people were in different groups of customers and how much those groups spent on food and beverages. based on the scatter plot, how much money would a group of 10 people be expected to spend? So again, back to scatter plots. Draw your trend line. We're going to go over to 10 people. And we just go up until we meet that trend line. So based on that trend line, I would estimate 135. If you estimated anywhere between 120 and 140, I would say that's a good estimate. If you're above that or below that, you might want to look at your trend line again and just make sure that you drew a good trend line that's balanced. Okay, your test is tomorrow. Make sure you have this review completed before you get to class.